Installing a three-way switch is a complex wiring challenge that we'll make simple for you to understand. You would install a three-way switch if you wanted to turn lights on or off from two different locations in your home. This wiring arrangement comes in handy in long hallways, up and down stairs, and across large rooms. Let's start from the beginning. You must first understand that a three-way switch is different than the single-pole switch we have already discussed. Here's a close-up look at a three-way switch. As you can see, this switch has a dark-colored terminal screw on the bottom. This screw is called the common screw. These other two screws are called traveler screws. This last screw is the ground terminal. A three-way switch doesn't have a regular on and off position like a single-pole switch, so you'll never see any on-off wording on the switch. Instead, a three-way switch is designed only to redirect the flow of electricity between the common screw and the left traveler screw, or from the common screw to the right traveler screw. That's it. Three-way switches will vary slightly according to the manufacturer. But with the switch we're using in our example, when this switch is in the down position, the current passes between the common screw and the left traveler screw. When the switch is in the up position, the current passes between the common screw and the right traveler screw. Again, three-way switches differ by manufacturer, but once you learn the concepts we'll show you, you'll be able to use and understand nearly any three-way switch on the market. Here is a look at a possible three-way switch scenario. We have our electrical cables, two separate three-way switches, and a light fixture located at the end of this run. You can set up a three-way switch any way that suits your lighting needs. You can position the light between the two switches, or you can move the light into the first position on the circuit, followed by the two switches. In this example, we will move the light to the end of the circuit for an easier explanation. The incoming power cable is a two-conductor cable with a hot, neutral, and a ground wire. Between the two switches, we will use a different type of cable. This cable is a three-conductor cable that contains an extra wire. So instead of your regular two-conductor black, white, and copper wires, this cable contains an extra red wire. We'll show you how to use this wire in a moment. This last cable, leading away from our second switch to the light, is a regular two-conductor cable like we've used before. Now we'll see how easy it is to wire all this together. When the incoming cable from the power source arrives at the first three-way switch, you connect the hot lead to the dark common terminal screw. Next, the black and red wires from the three-conductor cable that runs between the switches connect to the traveler screws on this switch. In this example, we want you to connect the black wire to the left traveler screw and the red wire to the right traveler screw. These wires are now known as traveler wires. They travel from the first switch location over to the second switch location. At the second switch, you connect these wires to the same traveler screws. Again, in this case, connect the black wire to the left traveler screw and the red wire to the right traveler screw. Next, you connect the black wire from the cable leading to the light fixture to the dark common screw on the second switch. This common screw is the hot terminal that supplies the power out to the light. Now, let's see how a three-way switch works when in action. Electrical current travels from the power source and arrives at the common screw on the first terminal. The current will either try to pass to the traveler screw on the left or the traveler screw on the right. In our example, since the switch is in the down position, the current passes to the traveler screw on the left and will then try to travel along the black traveler wire until it reaches the second switch. If the second switch is in the up position, the current will stop, having nowhere to go. In this case, the light will be off. If the switch is in the down position, the arriving current will pass through to the common terminal screw and continue out to illuminate the light. The same will work if the electrical current arriving to switch number 1's common screw finds that the switch is in the up position. The current will attempt to pass to the right traveler terminal screw and will try to continue along the red traveler wire. When it reaches the second terminal, it will stop if the switch is in the down position. If the switch is in the up position, the current will pass through to the common terminal and then out to illuminate the light. To complete the wiring of this three-way switch example, connect the neutral white wires together at every position, securing them with the use of a wire nut. Then do the same for your ground wires. Use pigtails to make connections to the ground terminals on the switches and to any metal box on this circuit.